going on, guys? In this video we are going to see how to prove this proposition. Here the proposition says for all x y belongs to integer, if x divides y, then x divides absolute value of y. Okay, here we are going to have two cases. One can be like y can be greater than 0, greater than or equal to 0, or y can be less than 0. If y is greater than or equal to 0, like we can say that's a positive y, or it's going to be 0. Then if it's less than 0, it's going to be it's mean it's negative. Okay, so let's see the cases. First we are going to say let xy belongs to integer as it mentioned in the proposition, and also we are going to assume x divides y as it mentioned in the proposition. Here our claim is, whenever we have if then statement, the claim is the one that comes after then. This is what we have to prove. Okay, this is our claim, and this is the one we are going to use to prove this claim. Okay, so first assume x divides y, then let t belongs to an integer with y is equal to xt. Here t is an integer, that's x divides y, because if you rearrange this one you will get y over x, it means x divides y. Okay, that's why we write this one in this way. Now let's look at the first case. The case 1 is 0 is less than or equal to y. Okay, y is greater than or equal to 0. It means y is a positive number or it's going to be 0. In this case we can say absolute value of y is equal to y, because if it's a positive number, if you take the absolute value, it's still going to be the same. And since x divides y, because we can use this one. If we have if then statement, whatever the things that comes after if, we use that one to prove this one. Since it's mentioned that x divides y, so we can say x divides y. So we have that x divides absolute value of y, because we saw that absolute value is equal to y. So if x divides y, then x divides absolute value of y. Now let's look at the other case. The other case is case 2. The case 2 is if y is less than 0. If y is less than 0, it's going to be negative. In this case, absolute value of y is equal to negative y. Now here we are going to put s is equal to negative t. Then since y is equal to x times t, x times t. Okay, like this, same one we saw before, because x divides y, if you rearrange this one, t will be equal to y over x. That's why since y is equal to x times t, we have, if it's negative y, then it's going to be x times negative t. Okay, then we can say hence, that's why we introduced s is equal to negative t. Instead of this negative t, we are going to replace that one with s, and instead of this negative y, we are going to put the absolute value, because for y is less than 0, absolute value of y is equal to negative y. So instead of negative y, we can put absolute value of y, and instead of this negative t, I will put this s. Okay, from this one you can see here we have s, that's the value that divides absolute value of y with x. X divides absolute value of y. That's what we have to prove in the proposition. That's what the claim is. Okay, the claim is x divides absolute value of y. Here we proved this one, so we can mention that here. Therefore there exists s belongs to integer, absolute value of y is equal to x times s. This shows that x divides absolute value of y. Okay, finally we can conclude this one as, let's use a different color. We can conclude this one as, therefore if x divides y, then x divides absolute value of y. Okay, that's what we want to prove. I hope you guys find this video helpful. Thanks for watching. And if you are trying to learn discrete mathematics, there are a bunch of videos in my playlist. I hope you guys watch that too. And don't forget to subscribe. See you next time.